Welcome back to Enzymes, Biological Catalysts. This time, we will look at some other factors that affect the activity of enzymes. To get the most out of the videos, I recommend that you watch them in order. This is a reminder that this presentation is Dr. Johnson's intellectual property. Aside from the orientation of the reacting groups within the active site and stabilization of the transition state, there are other factors that affect the activity of enzymes. pH and temperature are often contributing factors. We'll discuss pH on the next slide. Just like there is with chemical reactions, increased temperature increases the rate of enzymatic reactions. However, the enzyme is a protein. Therefore, as the temperature increases, the enzyme will undergo thermal denaturation, which renders it inactive. The temperature often depends on the organism. For most organisms, the temperature at which denaturation begins is around 40 degrees. However, for thermophilic organisms, the temperature required for denaturation could be well over 100 degrees Celsius. Ionic strength also affects enzyme solubility and stability, as well as substrate and product solubility. There are additional factors that affect the observed activity: substrate and enzyme concentration, inhibitors and activators, and covalent modifications. This table shows you that there is a wide range of optimal pH values for enzymes, and these are not ones from extremophiles. While many of the optimal pH values center around the pH of the enzyme's normal environment, this is not always the case. There are two different factors that go into the optimal pH for an enzyme. First of all, we must keep in mind that enzymes are proteins and are not very stable and tend to denature at extremes of pH. They are often most stable near their pI values. The other factor, which is possibly more important, is that the catalytic residues could be ionizable. In other words, they can be protonated or deprotonated. If they have the wrong ionization, their activity is diminished. These graphs of enzyme activity as a function of pH are essentially titration curves. The inflection point is at the pKa for the ionizable residue. The pKa value can help us identify the amino acid, but we must be cautious since the pKa values can be perturbed by 1 to 2 units from those of the free amino acids. The optimal pH is at the high plateau. The curve on the left is for an enzyme that is more active at pH values lower than the pKa, indicating the acidic or protonated form of the residue is required. The curve on the right is for an enzyme that is more active at pH values greater than the pKa, indicating the basic or deprotonated form of the residue is required. One other interpretation of these curves is that if the substrate is ionizable, its ionization can affect the observed binding and chemistry. While important, this is not considered as often as the ionization of the active site residues. This is a curve for an enzyme with 2 pKa values. The optimal pH lies between these values. This shows us that the enzyme has 2 ionizable residues, one that needs to be deprotonated and the other that needs to be protonated. Enzymes can be selective for certain substrates, excluding others from reaction. This is the origin of the concept arising from Emil Fischer's comment that led to the lock and key theory. Specificity is controlled by the structure of the enzyme's active site and the fit of the substrate into this site. Substrates that fit better will have higher yields of product. Other enzymes are referred to as promiscuous. They show little discrimination amongst a variety of substrates. These generalist enzymes have important roles. Reacting with many different substrates keeps the body from having to produce a larger number of specific enzymes. In this video series, we discuss the origins of enzymology, enzyme catalysis and rate enhancement, the reactive groups in enzyme active sites, and various factors affecting activity. Thank you for watching. If you found the videos useful, please like, share, and subscribe.